Hi, this is Mrs. Cribb. We're going to start working on this worksheet, Predicting Products of Chemical Reactions and Word Equations. So please pull this out, and anything that we don't do in class, you'll do as homework. You're going to need to write the balanced equation, tell what kind of reaction it is. So synthesis will be an S, SR for single replacement, DR for double replacement, DC for decombustion, or decomposition rather, and C for composition. Combustion. So DC for decomposition and C for combustion. And if no reaction can happen, it's an NR. And so in order to do all this, you're going to need all of your reference charts. So pull out your activity series, your oxidation chart, and your polyatomic ion chart. If you need to, also pull out your periodic chart. Some things that you need to remember are the pattern for the polyatomic ions. So it's per 8, ite, and hypoite. So remember that. Per 8, 8ite, hypoite. Per 8, 8ite, hypoite. And you also need to remember how to turn polyatomic ions into acid names. So 8 becomes ic. So the polyatomic ions that end in 8 become ic acids. And ite become us acids. Remember, we say aidigitis, so it sounds like a disease, aidigitis. So us acids come from the ite polyatomic ions, and ic acids come from the 8 polyatomic ions. All right, let's start off with the example. Magnesium bromide. First you have magnesium, Mg, and bromine. Remember, the "ide" endings mean that these are just elements. So "ide" endings mean you only have elements. It's not a polyatomic ion or an acid. And magnesium has a +2 charge if you look on the polyatomic ion sheet, the oxidation chart, and bromine has a -1 charge. And then chlorine is Cl, but chlorine is diatomic. So you also have to remember all your diatomic elements. And so what are those, guys? Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine or iodine. So say it. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So we got to remember all those. So chlorine then won't just be a Cl, it'll be a Cl with a subscript of a 2. I say, now what do we have here? We have a molecule with a positive and a negative, and then we have this poor little single all by itself sitting over here. So what kind of reaction, what can happen? The chlorine can take the place of the magnesium or the bromine. Now, magnesium is positive, and chlorine is normally a -1 charge, so chlorine is going to take the place of the bromine. So magnesium is a +2, chlorine's a -1. Swap and drop, put the charges on the top, swap and drop, so bring it down. And then we have bromine over here, and bromine is one of those polyatomic ions, so bromine also has to have a subscript of a 2. Now notice, chlorine replaced bromine. Chlorine replaced bromine. And if you want to look on your activity series, you can see if that is a possibility. I'm going to pull one up. So that's the oxidation chart. We're going to pull that up periodically. And I think there we go. Activity series. Let's see. Oh, I didn't put the halogens on this particular thing, but you can look at your own activity series in your polyatomic ions, and you can see that chlorine can replace bromine. So this is there's that little single guy, and there's another little single guy, so that's a single replacement reaction. Remember the dancing, okay? Now we need to balance this equation. So we list the elements on the reactant side, magnesium and bromine and chlorine. I'll just put it over here. And we count them. So we got to swap and drop on this one too. Swap and drop, so there's a 2. And swap and drop, okay, we did. So we have 1 magnesium goes to 1. We have 2 bromines goes to 2, and 2 chlorines goes to 2. So in this case, it's already balanced, so I don't have to do any adjusting. So you don't have to write already balanced, but I'm just putting that on here so you can notice that. So that is the example. Now let's skip down. We're going to do number 4. Alright, so now on number 4 we have sulfuric acid. Now sulfuric acid is on the list of those you have to memorize, but I also want you to remember that 8 endings become ic acids. Okay, so sulfuric acid comes from the sulfate ion because ic comes from the 8. So let's pull up the polyatomic ion sheet. Nope, not that one. There it is. Okay, let's see. Do we have sulfate? Yep, SO4 with a 2 minus. It's SO4 with a 2 minus. So let's go back over here and write that down. SO4 with a -2 charge. That's the sulfate ion. The sulfate would become the ic acid. Okay, so sulfate, now that -2 means I have to have 2 hydrogens to cancel it out because a hydrogen is a +1 charge. So this is sulfuric acid, and it's going to react with sodium hydroxide. Sodium is Na. Hydroxide is another polyatomic ion you need to know, which is OH. Sodium's a +1, hydroxide's a -1. And that's already swapped and dropped, and here that's swapped and dropped because we do it automatically when we add those hydrogens in to cancel out the -2 charge. So now, what kind of reaction will this be? Well, we have a couple and a couple, and they're going to switch partners. Remember that? So the positive is going to go with the other negative, and this positive is going to go with this negative. So let's start off with that. Okay, sodium, Na, goes with SO4. Alright, so SO4 is a -2 and sodium is a +1, so we swap and drop, put the 2 down here, and that's all we have to do. Because and now the second couple, we have to have this negative going with this positive. Now what I like to do is write just like that, just write what it is. We have the H has to go with the OH. Now you'll notice that this can also be written as H2O, but when we're doing the balancing, I really would prefer you go ahead and write it like this so you can see the OHs on both sides. Okay? Now, hydrogen is a +1 charge and oxygen is a -1 charge. Notice that there are 2 hydrogens right here, but I did not write 2 hydrogens over here. All you do is write the atom type or the polyatomic ion. Put the charges on the top, swap and drop. And since they already cancel each other out, you don't have to swap and drop here. Alright, this then is a double replacement reaction. And so now we just need to balance it. We have hydrogen, sulfate, SO4, sodiums, and OHs, hydroxides. Now, so count them. We have 2 hydrogens, and then over here we have 1 hydrogen. So see that? 2 hydrogens, 1 hydrogen. Sulfate, we have 1 sulfate over here, and over on the product side also 1. So, sodiums, we have 1 sodium, and on the product side we have 2. And then OHs, we have 1 OH, and on the product side we have a 1 OH. Okay, so let's work on balancing. I'm going to use black because I haven't used black. Weird, huh? So 2 and only 1 hydrogen. I know it looks like there's 2, but that other hydrogen is stuck in that OH. So the just plain old hydrogens, there's only 1. So I'm going to put a 2 in front. That's going to change my count. Now I have 2 hydrogens and I have 2 OHs. Because this has to multiply the hydrogen by 2 and the polyatomic ion OH by 2. Alright, so now I got to correct this. I need 2 OHs. So put a 2 in front here. Remember, you can only put coefficients in front. You cannot put them in the middle anywhere. This now gives me 2 sodiums, because 2 of those, and 2 OHs. And that should balance this equation. So everything looks balanced now, and that's the end of this one. Okay? All right, now let's do number 6 together. We have aluminum, and it's not diatomic, plus oxygen, and oxygen is one of the diatomics. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So oxygen. Okay, now the only thing we can do here, we have 2 singles. What's the only thing they can do? The only thing they can do is come together to make something. So aluminum and oxygen. Aluminum is a +3 charge on your oxidation chart. Yay, I finally pulled up the right one. There it is. It's +3. It's really hard to see on this thing. I apologize for that. But it's a +3 charge. Whoops. There we go. And oxygen is a -2 charge on your oxidation chart. Put the charges on the top. Swap and drop. Bring down the 2 here. Bring the 3 to the other side. Okay. So what did I do? I took a single, and they started dancing together. So that is a combination or synthesis reaction in this case. Synthesis. We're going to use S for synthesis. All right, now let's just balance this thing. We have aluminum, oxygen, and that's it. Only 2 things. On this side, we have 2 oxygens, and on the product side, we have 3. And on this side we have 1 aluminum, and on the product side we have 2. Okay, so you can start off with the aluminums or the oxygens. I'm going to start off with the oxygens this time, and you may think, why am I doing that? And that's because they appear in groups of 2. When you only have one thing all by itself, it's very easy to adjust that number. So when this one comes in only groups of 2, so that's usually harder. So I have 2 and 3. So this is that least common multiple. The least common multiple of 2 and 3 is 6. So 6 divided by 2 is a 3. I'm going to put a 3 on this side. So now I have 3 times 2 is 6 oxygens. And then 6 divided by 3 is a 2. So I'm going to put a 2 on this side. So now I have 2 times 3 is 6 oxygens. But it also messes up aluminum. So 2 times 2 is now 4 aluminum. Because aluminum comes all by itself, it's very easy to fix. So have a 4. And that makes it a balanced equation. All right, let's go on. We're going to do number 15. Okay. And I want to show you all these. Some of them I give you the whole thing, and some of them you're going to have to figure it out. And I try to help you, giving you clues. But let's do number 15. It's one of those where we have a fuel, and I went ahead and gave it to you. Plus oxygen produces, remember that's always a line, carbon dioxide and water. So what is this? What always produces CO2 and water? So C6H12 plus oxygen. Oxygen is diatomic. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So there it is. Produces CO2 and water, H2O. Okay, so whenever we produce carbon dioxide and water, this is a combustion reaction. Okay, and it's also going to produce heat. We're not going to talk about the heat too much until a little bit later when we get into a little more details about reactions. So now we got to balance this, and remember these kind are often the hardest, and there's more than one way to do it. I've shown you a couple of different ways already. So what I'm going to do this time is I'm going to use the idea of trying to make the carbons divisible by 4. There's more than one way. You can also make the hydrogens divisible by 4. So in this case I'm going to make the carbons divisible by 4 just so I can bring up a point. Okay, so 6 is not divisible by 4. But if I put a 2 up here, 2 times 6 is 12. And that is a number divisible by 4. So I'm going to start off with 12 carbons on this side, but only 1 on the other side. And then 2 times 12 is 24 hydrogens on the reactant side and only 2 on the product side. 2 oxygens on the reactant side and 3 on the product side, because you have to count the oxygens here and here. I'm going to go ahead and change my color now. Look, okay. All right, now let's start doing some finagling. I need to fix the carbon, so I put a 12 in front. All right, that gives me 12 carbon now, but that messes up my oxygen count. So 12 times 2 is 24 oxygens plus one more is 25 oxygens. Okay? So change that to 25. All right, now I need to fix my hydrogen count. Well, I have 24 on this side, so I need 24 on this side. So 24 divided by 2 is a 12. So 12 times 2 is now 24 hydrogens, but that messes up my oxygen count again. So now I have 12 times 2 is 24 oxygens plus 12 more. And so what does that equal? That equals 36 total oxygens. Right? All right, so I need 36 oxygens on this other side, but they come in groups of 2. So I'm going to take my 36 and divide it by 2, and I get 18. And I'm going to put it here. And you're going to say, okay, great, this is awesome. Everything is balanced. And that's true. Everything would be balanced at this point. But notice this. We have 2, 18, 12, and 12. All those are even numbers. When you're doing this, the goal is to get the most reduced number of coefficients. So I got to reduce this just like I would do fractions. So everything can be divided by 2. So this becomes a 1, this becomes a 9, this becomes a 6, and this becomes a 6. I divided all the coefficients by 2. And now double check. I have 6 carbons and 12 hydrogens. Okay? Sorry. 6 carbons on this side and 6 on the other side. All right, I have 12 hydrogens on this side, and on here 6 times 2 is 12 hydrogens. I have 18 oxygens on the reactant side, and then 6 times 2 is 12 oxygens plus 6 more, that's 18 again. So 18 oxygens. So it still balances, but I reduced all the coefficients. So that probably seems like a lot of work. All right, let's go down to number 18. All right, let's see what we got. Now, zinc carbonate. All right, zinc, Zn. If you look on your oxidation chart, zinc has a +2 charge. So make sure you're looking at that. And then carbonate. Remember, anything that ends in ate or ite is a polyatomic ion. So let's look at our polyatomic ion sheet. Not that one, this one. Okay, carbonate. If you look at carbonate, CO3. Now this sheet is different than what you have. Yours, you have a lot more, and they're in alphabetical order. But CO3 2-, that is the carbonate ion. So I'm going to write CO3, and it's a 2-. Notice they already cancel each other out, so there's no swapping and dropping necessary. Zinc carbonate, what does it produce? It produces zinc oxide. Zinc's a +2 and oxygen is a -2. They cancel each other out already. And carbon dioxide, CO2. All right, so what do we have? We have one thing in the reactant side, and it doesn't look like this is a molecule the way I've written it. I think I'll just scooch it over a little bit. Zinc. We have one thing on the reactant side, and it falls apart into different things on the product side. So whenever you take something and break it apart, that is decomposition. It's breaking apart. All right, now we need to balance it. All right, so zinc, we have one zinc and one zinc. One here, one here. And then carbonate, we can't do that. Notice it's CO3. This is a CO2, so it fell apart. So we're going to have to count each atom. We have one carbon and one carbon. And then oxygens. We have 3 oxygens, and then we have 1 here and 2 here. So that's 3 oxygens. So this one is already balanced, which is kind of nice. We don't have to do anything else with this guy. All right, number 19. There's another ic acid. And this one comes, it says acid, acetic. That means it comes from acetate. Because remember again, 8 becomes ic. Atic, itis. 8s become ics, so ics have to become 8s. Atic, itis. So let's go look for acetate. Now I don't know if the one I pulled up actually has that on there. Oh, it does. C2H3O2 with a negative charge. So we're going to write that in there. Acetic acid. C2H3O2, and it has a -1 charge. Alright, so how many hydrogens do I need to cancel out -1? Only one of them, and it'd have a +1 charge. And then we're going to add copper, Cu. Now, if this was going to work, we have a single, and it's going to replace, so we end up with copper, and copper can have a +1 charge, and then C2H3O2 with a -1 charge, and then we'd have hydrogen, and it's diatomic. Hydrogen, nitrogen, oxygen, so H2. But you have to make sure that copper can replace hydrogen. And so you need to look at your reactivity series. So I pulled up this one. There's hydrogen right there. Where's copper? If copper can replace it, it has to be above it. But it's not. It's below it. So it cannot happen. Copper is below hydrogen, so it cannot replace the hydrogen. So in this case, no other work is need to be done. This is no reaction. No reaction can take place. Okay, this is where I'm going to stop. So I've done several of them for you. The rest of them I want you to work together in class, and whatever you don't complete, you're going to need to do at home. And I will be sending the key. Good luck.